close out. We have a really great session to start us up today. We have Jose Barajas, the Director of Global Sales Engineering for AttackIQ, leading us off today with a presentation on the case for continuous security validation. Without further ado, Jose, please take to the virtual stage.
Hi, everyone. Thanks for having me today, and thanks for that introduction. Like you said, today the goal is to talk about the case for continuous security validation. So let's go ahead and just jump right in, and let's have a conversation about this. Please feel free to add questions to the chat. I'll definitely finish up my thoughts and come back and answer those as I address them. And to start, I want to say hello from San Diego, California. This is where I grew up myself, and I've developed my career here out of San Diego. As you said, I'm the VP of Global Sales Engineering here at AttackIQ. So I actually lead the organization globally from that perspective. Also, for those of you that are familiar with MITRE, I actually lead the research on behalf of the company. We've conducted a lot of research with them. My background and how I ended up in cyber, I know all of us end up here and take many different paths to get here. I actually started off as a web developer. And for those of you who have been around long enough to know what Flash is, when Flash was a problem, I knew how to reverse engineer that because I was doing that as a web developer anyways. And that led to me having over 10 years as a researcher, which means I used to reverse engineer malware. I studied, command and control communication and developed a number of sandboxing technologies and other technologies in my career. And for the last 8 years, I've been here at AttackIQ, focused on the concept of continuous security validation. Now, today we're talking about the case for continuous security validation. And really the agenda today is to first and foremost talk about the problem, right? What problem are we addressing? Why should you implement a continuous security validation program at your organization? And by the way, it doesn't have to be an entire program. Even doing things here and there are going to be super helpful, as you'll see when I talk about this a little bit later. I then want to talk about how we've solved this problem before. As an industry, we've solved this before, not necessarily for cyber yet. That's why we're having this conversation, but in other industries. And you'll hear me use the analogy of IT service management as an example. From there, I want to give you some pointers on where to start. How do you build a program? How does your team get started with this? Part of the work that we did with MITRE was develop resources for this to democratize it so that not only the Fortune 2000 can have access to this. And then finally, how you can learn some more and start to address some of this yourselves as part of your processes. So that's what I have in store for today. Again, please feel free to ask questions along the way. But to start, let's talk a little bit about the problem that we have in our industry today. And I'd like to start, before we get into it, with a little bit of a question here. And I want you to think in your own mind, rate your confidence in your security control effectiveness. We actually did a study on this. I'll give you the numbers in a little bit. But from my experience, there's really a spectrum of responses I get when I ask this question to an organization. And it really ranges from, my stuff works all the time, right? Of course it works, to, others that are like, I hope it works. We definitely see that one quite a lot. Another one I see quite a lot of is, my vendors confirm that their products are working solid. Said differently, I bought the best in breed. What else could I have done? By the way, that answer is no longer valid, no longer accepted. We have to ensure that we're not just buying best in breed, but actually managing those solutions correctly. So again, more on that a little bit more. Others will bring up the pen test. I did a pen test last year, so I think I'm good. And then others, this is my favorite. I don't really want to know. I like to frame this as the ostrich with their head in the sand. Said differently, I've had folks tell me, my executives, they don't want to know, because if they know, it means they actually have to do something about it. So really, this is a spectrum of confidence that organizations have around their security controls. And, on average, organizations are spending about $20 million a year on cybersecurity. But yet, this is the kind of ambiguous feedback that we get when this very simple question is asked. And, the reality is, as an industry, we're spending $100 billion annually in cybersecurity, and we're still in the dark on whether we're actually protected. And at AttackIQ, we actually did a study with over almost just shy of 300 cybersecurity executives, and 56% of them said they were not confident that their security controls were effective. That means they spent, again, between 2 to 20 million a year in their cybersecurity programs, but 56% of them were not confident that they were actually effective in accomplishing the goals and objectives of that investment, which is to keep your organization secure. Now, from there, the other thing I'd like to call out here is, we've actually been doing research with the Verizon. We've contributed to the Verizon DBIR report for the last 5 years. And the continuous finding and feedback from that report is that 82% of breaches should have been stopped with the security controls that the organization had, but they weren't. What that meant is the company had purchased the right technology. However, that technology was not effective when it mattered most, essentially when the attacker was actually at their doorstep, and actually was successful because those controls weren't successfully deployed and actually were not effective. That's really the problem that we're facing today, is we're making the right investments. We're just not implementing those investments and ensuring that those investments are providing the value that they should be providing to us. Now, so far we've talked a little bit about kind of the problem that we're facing. The way that you probably see this problem is from questions that you're getting either from your board, your regulators, your insurers, or even other departments within your organization. And definitely the thing I saw every single day as my days as a researcher, which is we saw something in the news. What is our ability to mitigate that? Is it even relevant to us, and should we even care? And this question used to come, maybe from executives, but we're seeing it more and more that the board directly is asking, right, what are we doing about this? How are we being proactive? From there, something else that I'm seeing is the question of what technologies are using to mitigate threats. This is a question that we've been getting for quite some time, and we'll talk about our technology stack. We can talk about our pen test cadence, and that's a great way of answering that question. And we're still getting that question today. But what I've seen, and I'll use an example from the financial segment, which is GLBA, which is a regulator for the financial services industry, is starting to shift this question. So instead of asking what technology are you using to mitigate current threats, they're asking, can you prove you have the ability to mitigate ransomware or swap in whatever threat that you have? That's a very, very different question. And it really begs a very, very different answer, right? You have to prove that your technology is actually working and effective, not just that you bought it and that it's installed somewhere. Beyond that, we're starting to get more questions around the investment that we're making. The trend that I'm seeing, and a lot of folks like Forrester are also confirming this, is organizations, their budgets are not becoming this open checkbook that we've seen in the last 5 to 10 years. They're starting to get asked the same questions that IT, service management, or frankly, any other part of the business is getting asked, which is how are we measuring the effectiveness of this investment, right? Why do we need more dollars? What are we doing with the current dollars? So that's a question that our security teams are now having to start to answer. And then finally, what are our plans to adopt a red team, purple team model? If you're not familiar with these terms, this is definitely something that we're starting to see more and more from our perspective, where the board of directors, maybe executives are going to local events like InfraGard, which is FBI is highly involved in that. And they're talking about the needs for a red team. They're talking about the needs for a purple team. And what that means is that those same board of directors, those same executives are coming back to you and asking, are we doing this? Are we heading this direction? Why aren't we doing this today? So this is the type of questioning that we're seeing, and why really you should be implementing a continuous security validation program to ensure that you're getting ahead of the questions that we're seeing here. Now, the impact across the organization in essentially not having appropriately installed or configured security solutions that you've already invested in really play themselves out very differently across different parts of your business. So if you have a threat management group, for example, they're going to be too focused on, maybe IOCs, essentially chasing the incidents of compromise. A lot of organizations don't even have the luxury of having a threat management dedicated organization. And then finally, this is not a standardized discipline today. What this means is that you don't know what you're up against, right? Again, you're spending between $2 and $20 million in cybersecurity program. How do you know that those dollars went to the right solutions, went to the right technologies in order to make you safer day after day? From a risk management perspective, what ends up happening is, we're not going to have a true understanding of the risk. The focus of risk management is typically very much focused on compliance, and it should be right, because there can be a huge amount There can be a huge amount of regulatory compliance needs, which means you're going to get fined if you don't meet those. But at the same time, this might mean that you're making bad security investments because the risk is not understood and you're just checking a box versus trying to understand what's going to really make you secure. From a security operations perspective, there's going to be this dependence on the technology, the monitoring controls or technologies that are deployed. If they're not functional, if they're not working, and if those alarms aren't going off, your security team is going to be miss an incident altogether. Or maybe an incident is identified, but then you realize that your firewall hasn't been logging for the last 12 weeks, which means it's going to be impossible for you to come to a determination. Either you or maybe an outside firm that needs to come in here and investigate. The context is simply not there. And then finally, from a security testing perspective, we are doing it today. This is in the form of pen tests, external red teams, but these are very costly, right? It takes people to do these. They're temporal, which means they could come in today and everything is working, right? But that doesn't mean it's going to be working tomorrow. And then finally, at the end of the day, this just doesn't do enough. And to address some of those questions in terms of, red team and purple teams, I would say, from a red team perspective, doing it every once in a while, every 6 months, every 12 months, depending on your perspective, definitely matters. The purple team, however, this is not, something that you do. This is actually a program that you stand up. So, and essentially when it comes to a red team, having that purple team's construct, meaning that your red team is feeding into your security team so that you can work together to get better. Because what we've seen historically is red teams come in and say, hey, I own your environment. Here's your report. Have a nice day. That's not making you better, more secure. This purple team construct is. Yeah, and I think we definitely don't want to get lax in our defensive strategies. I'm noting a little banter here. The idea here is let's just not implement those controls, but let's actually go ahead and make sure that the investment is actually effective. And again, if you're familiar with the change in IT service management, right, it's very similar to that kind of demand that IT had. And, Brian, you actually teed me up perfectly for this next piece. What I want to talk about next is the fact that, this is actually costing all of us. This is actually a few charts that I'm going to show you now from Marsh, one of the top insurers in the country. The United States GAO, Government of Accountability, actually used the same statistics for their analysis this year. And essentially, you can see the number of cybersecurity claims are actually increasing more and more year after year. We'll see where we actually land, in this year, but overall, it's just increasing over time, as you can see. Then, what this means too is we're seeing ransomware payments have increased in frequency since 2019. So again, what we're doing is not necessarily, the results from a results perspective. We're seeing more and more of this. And this is exactly why we need to maybe do something a little bit different to address this. And as you can see here, overall demands of just ransom in general and payments are also increasing. And just the small caveat here is essentially, right, folks that have done a good backup process to not have to pay the ransoms, overall ransom occurrence is increasing along with the payment. So our peers in our industry or in general, other corporations are paying this out, which means from my perspective as a researcher, attackers aren't going to stop. They're going to continue to go down this path because it's clearly going to be profitable for them. And I want to leave you with this last one here, which is cyber insurance rates are continuing to increase. In my experience, I have had customers being able to put a cap on their premium by showing that they've established a continuous security validation program. For those that don't have that, however, as you can see there, find your revenue there on the top left. What this means is that your insurance premiums are going up between 36 and 56 or up to 64% every single year, year after year. That's about 150,000 to 850,000 between 1 and 3 years that your premium is going to increase. Now, I don't know about you, but my insurance for my car isn't increasing between 36 to 56% every year. But for cybersecurity insurance, it is. So this is why it's so important to not only have effective security controls deployed, but validate that they're actually effective and working, which is kind of what I'm advocating for here today. And by the way, again, Marsh McClellan is where those stats were found. Our GAO office is also where these stats are found for those of you interested. and further information. Now, with that said, the problem that I'm talking about, we've invested a lot in cybersecurity controls. We don't necessarily know if they're effective, or at least based on Verizon, they're definitely not being deployed effectively. How have we actually solved this before? And before I get into that, I want to give you a picture of what we have to manage as cybersecurity practitioners, right? If we start here on the left, we have to first focus on endpoint technologies, making sure that the endpoints are checking in, that they're actually responding, that they're actually effective. Enterprise organizations that I work with, they can't get more than 80% of their topology checking in, meaning that no more than at any moment, no more than 80% of their assets actually have agents installed, deployed, and checking in, which means you don't actually have the full picture, let alone those that are deployed may not be providing the feedback that they should. The next, we're looking here at things like sensors. Think of like network sensors. If you're on the cloud, they have things like AWS Cloud. From that perspective, very easy to misconfigure these. And like I said, I've seen situations where an organization gets compromised and they figure out that apparently the firewall hasn't been logging for the 12 weeks, meaning investigation is extremely difficult. From here, we can then see that we have a number of different technologies such as SIMs that are going to aggregate your technology details, do statistical analysis and provide some correlation details there. Again, if the logs aren't flowing in, none of this matters. Even if you have a perfect system, if it doesn't have the context it needs to do its job, it's going to be irrelevant. From here, we then have other technologies here that are going to do asset management, do internal threat analysis that we might have issues with. As we deploy more and more technologies, we're all becoming application technologies. So from here, things like API changes are going to affect your processes and workflows. And then finally, there on the right, we definitely have training and readiness programs, or we should, for our users. However, what I always like to say is we could have gotten everything right to the left of the user. None of that matters if one of our employees still downloads a malicious Word document and opens it with macros, right? Essentially running on brand new vulnerability. So from that perspective, this is very, very difficult. And all of this needs to be working together in order for it to be an effective control. So this is the problem that we're facing. And in terms of how we solved this before, I actually like to use this analogy. I fly a lot. I see into the cockpit of the plane, and we can see here, there's a ton of different knobs, ton of different gauges that you can see there. At the end of the day, I like to frame this as a systems engineering problem. And, the pilot knows, if you can see those 4 little green dots on the right side of that picture, the pilot knows exactly what that means, right? If it turns yellow, if it turns red, it knows what gauge to look at to understand what the status of it is, what other knobs to flip or switch in order to correct that, and then know what to do in order to get it back into that green state. This is exactly what we're missing for cybersecurity programs today. We've deployed a bunch of stuff. We have a bunch of logging and a bunch of dashboards, but when something fails, something's no longer logging, something that's showing up, we don't have a process for that. It fails silently. When we're looking at the cockpit of a plane, if we suddenly get ice on the wings, there's going to be a big red alert telling us that there's ice on the wings, so that a mitigating item can be done in order to remove that ice from the wings, as an example. Again, this is what we're missing from the perspective of cybersecurity. And now the other analogy I like to use here, and I already see some of you mentioning things like NIST 853 and other kind of compliance frameworks. Well, there's actually a standard here, NFPA 25. And this is actually for maintenance and ensuring that the control against fire, this little pipe that you see right there, is actually effective and working. And at my last apartment building that I lived, I didn't have to think about this. It wasn't on my mind, but I can tell you that the building owners and the fire department knew the mean time to failure, the mean time to repair, which meant that they came in there every 6 months to do an inspection and validate that this pipe is actually still working and effective, because they knew that the mean time for failure was about 6 to 8 months. So this is an example of how we've addressed this, right, from the perspective of a plane, from the perspective of managing our office buildings. And since this is remote, for those of you at home, if you look up, you probably have a fire alarm. Now, I don't know if the last time you bought a fire alarm, but if you go to the store, this thing is going to cost between $5 and $10 at your local Lowe's. Even that has a feedback loop that our $2 to $20 million investments don't, which means I can push a button and it's going to scream, letting me know that it's actually working, that it's actually effective, meaning this $5 device has a feedback loop that our $20 million cybersecurity program doesn't. So this is the same thing that we need to be doing for our cybersecurity programs. And I've referenced IT service management a few times. They've created processes where fake tickets are generated, fake tickets are processed in order to ensure that the system is functional and that the system is working. Again, this is the same things that we need to implement for our cybersecurity programs today. Now, with that said, where do you actually start and how do you approach validating that your security controls are working effectively? First and foremost, I'd like to mention, for those of you that may not know, there's first this MITRE ATT&CK framework. If you're familiar with vulnerabilities, MITRE CVE, think of this as the other side of that coin, which is going to be MITRE ATT&CK. MITRE CVE describes the vulnerabilities that attackers can use most of the time to get inside of your environment. By the way, there's about 20,000 novel vulnerabilities every single year. MITRE ATT&CK is going to describe what attackers are going to do once they're inside of your environment. By the way, there's about 50 novel MITRE tactics techniques every single year. That's a much more manageable problem. And what this means for your cybersecurity practitioners is MITRE ATT&CK is the framework for them to understand current threats and current threats specific to them. As you can see here, we have this APT group, APT 29. It's known to target political organizations. So if you're a political organization, as a cybersecurity analyst at that organization, we can take a look at the information that MITRE ATT&CK has presented us to help us understand what are the tactics, techniques, and procedures that our attackers are using against me or other financial, or I should say political organizations, so that you can focus on the areas that are going to have the most impact within your organization. And what this really does is it draws a picture across all of these threats that we know across the threat landscape globally. The items in red and the items in yellow are the items that I should focus on most, because the attackers that are targeting my industry, this is what they're using. So this really gives us a basis to, first of all, understand where should I be making my cybersecurity investments. Now, from there, in order to actually help validate your security controls, one of the research projects that we funded and were participants on was the Adversary Emulations Plan Library. The Adversary Emulations Plan Library was actually developed not just by AttackIQ, but AttackIQ working with the MITRE Ingenuity Group and a number of other sponsors that you see here. And we've developed a number of different emulations plans for different attacker groups. And what this has allowed us to do is give you as security practitioners or your team as security practitioners an understanding of how these attackers operate, how you can actually recreate these attacks yourself to validate that your current cybersecurity program is effective in either detecting or mitigating outright these threats. And if you're finding a gap, for example, give you an opportunity to address those in a proactive manner. And how this research was conducted is we started off by, first and foremost, understanding all the different malware reports associated with a given threat. From there, we can do a detailed analysis to understand exactly step-by-step what the attacker has done. And then finally, we'll take in those TTPs in order to map out and paint a picture to the threat actor of how the threat actor operates. So in this example, we can see here how Fin6 operates. We actually give a nice brief. So instead of your team having to go out and read 40 different threat reports, we do one summary here. And as you can see here to the right, we showcase step-by-step exactly what the attacker has done, the decisions that are made in order to give you an understanding of what the attacker would have done with those environments. And I'm seeing a few comments here. It's definitely challenging to simulate attacks on production systems. I would not disagree with that, but at the same time, I think it's pivotal and important that you test in production systems. We see a number of customers try to test in replica VMs just to avoid a little bit more work. Those are going to be pristine systems that you just deployed and you just configured. They're definitely going to stop the bad things. What the problem really is when a system is out there sitting for 6 months at a time, the controls might not have been updated, might not be working, things might have changed. So that's, from my perspective, definitely would encourage you to do this in production. And guess what? Red teams, they're going to do it in production. They're not going to test in a VM because they'll tell you that that's just simply not effective there. And yeah, definitely, it's like I said, take some time, but definitely worth it, because that's where you're going to find the real problems. And by the way, not just in your technology, not just in your configuration of that technology, but even your processes. And I'll give you one example. Working with a bank in the Asia Pacific region, I was able to actually deploy on 5 Windows ATM servers. 4 of them blocked everything, 1 of them did not. What happened is because that one machine was not blocking things, we're able to compromise 160 other ATM machines, move laterally to about 80 of them, and exfiltrate data from those 80 machines. Now, the point I want to make here is they actually had the right technology. They actually had the right configuration. The problem was that the provisioning process did not appropriately deploy any of that technology onto that asset. That asset was put into production without the deployment process kicking off. So from that perspective, this is the reason why you test in production. And now that company has actually established a process where things get deployed. They have a standard set of tests that they do to make sure the deployment is effective, and then it gets pushed out of production. So this is just one example and reasons why you want to test in production. So just wanted to bring that up. Now, what this analysis that we did for this adversary emulation plan allows you to do is we're giving you the context so that you can, proactively engage in this threat. And what we do is we don't just tell you what the threat actor has done, what they've done step by step, but we actually have broken it down so that any analyst can go ahead and replicate this, whether it's on a cyber range, meaning a virtual environment. And, again, to the comments about testing in production is hard, start in a virtual environment. You may have some findings there, and that's how you're going to be able to convince the business that they should actually make the investments to test in production and find the problems here. And these emulation plans are going to give you step-by-step actions so that your team can actually replicate this. And by the way, you don't have to have super hot red team in order to do this. The reality is any user of your company, as long as they have access to a command line terminal, that's all you actually need in order to accomplish some of these testings. We've actually built this with this in mind. We didn't want to just build another, capability or function that only the global 2000s are going to be able to, implement. We actually wanted to democratize this information so that even a small business can actually go ahead and run some of these and make sure that their controls are actually working. So definitely encourage you and your analysts and your SOC to actually look into this so that you can actually start to do something within your environment. So that's one research project that we've provided to the community for them to actually be able to effectively implement some of this testing themselves. Again, whether it's as simple as just running things on one machine, or if you have a red team, how you can emulate to that degree the entire attacker kill chain as well. Now, something else I want to highlight now is going to be the MITRE evaluations. If you don't have the ability to run in production, as the chatter is going on about right now, or you simply don't have the time to maybe do some of this yourselves, because as we all know, we're all inundated. MITRE has actually done some of this for you, and what they have is they're called the MITRE evaluations. What they've done is they've chosen one threat actor every single year. You can see here from APT3 in 2018 to FIN7 in 2020. And what they've done is they've actually done the same work that we just saw previously, essentially mapping out what are the items that the attacker typically does, how does this play out step by step, and what types of environments were they actually targeting. So what the MITRE team did here is they set up a cyber range that replicated a typical corporate environment. They've gone ahead and set up the playbooks of what they want to run, and they've gone ahead and recreated this attack manually, essentially doing the red teaming for you in this replica environment. And their objective and goal is to understand what is the telemetry that is collected, what is the tactic and technique level that's implemented, what is going to be prevented, and what are the detections and analytics that are responding to these threats. What this means is what they've done is they've actually worked with the community, and they work with all these vendors. This is just a selection of them, by the way. So if you don't see your vendor, they probably were part of it too. And if they're not, I urge you to poke them to actually get involved in this process. But what this does is each of these vendors show up and they're putting their best foot forward. And what I mean by that is they actually also have recommended policies and configurations by which they're setting that foot forward. And what this allows your team to do is get an understanding, if you have any one of these vendors, to understand how it responded to the attack, what are the policies that they had in place in order to mitigate that attack, so that your team, without having to go do any of this process, can go and check, do I have those same configurations in my policies and configurations? If I don't, and if I have it off, why is that? Can we turn it on? So this is another way for you, without having to conduct any of this, red teaming, purple teaming, or proactive testing yourselves, but get this context that MITRE has done the work for you with your vendor specifically, so that you can compare and contrast essentially what you're seeing from your perspective as well. All right. Now, the last thing I want to talk about, and I included this simply because we're all going through some form of cloud transformation. I always like to say, even if you don't think you are. And from that perspective, from a perspective of cloud, the first thing I wanted to describe here is this concept of a joint responsibility model. Essentially, when you're working with Azure, same thing applies to AWS and GCP. There are certain things that you don't have to worry about. When I have to answer security review questions, when someone's purchasing our product here at AttackIQ, the beauty of when someone asks me, how are you managing physical access to the location? Do you have cameras? Do you have logging? So on and so forth. From a physical security perspective, I can just say Azure handles that. AWS handles that, because they do. They have the data centers. They control that access. I don't have to worry about any of that. Now, with that said, if I'm deploying a virtual machine, an application, or I'm hosting data, it is my responsibility, it's your responsibility to assure that you're deploying those in a safe manner, that the virtual machines aren't exposed to the world so that anyone can try to run vulnerabilities against them, that the applications don't have vulnerabilities themselves, and that the data isn't being exposed. What we found, in these last, 5 to 6 years, we've seen a number of massive misconfigurations where the data was just publicly available, meaning the attacker didn't even have to try. He just had to find the information and just hit download, and that's it. They just stole all your data. We've seen this countless times with a number of organizations, to include the Department of Defense here in the United States. And at the end of the day, what is this cloud stack mappings projects that I'm talking about? What we wanted to do with this research project was, again, help you ensure that you're employing the right controls within your security environment. So what we found, the problems were organizations today are definitely migrating to the cloud, again, whether they want to or not. Security controls are not really well known in the cloud. From that perspective, there's really no extensive resources available for you as an organization to close the gap there. And what we've seen is there's a ton of native controls available, but are not leveraged at all, or leveraged effectively from what we found as part of this research. By the way, for example, Azure has 38 different security controls available. I didn't know this before we did this research. So these are the kind of things that we wanted to highlight. And then finally, there's a lack of understanding between the threat. Again, what MITRE ATT&CK describes, there's actually a cloud version of MITRE ATT&CK that focuses on that. And then from that perspective, we mapped it to the security control there. And actually, Murali, that's a very, very good point. He said a lot of security programs that apply to on-prem does not apply to cloud. And that's exactly right. We're thinking about applying the same stuff that we've done historically to cloud, when these cloud environments really function completely different than on-prem. As a matter of fact, if we implement some of the best practices for on-prem, it might actually be the completely wrong thing to do in a cloud environment. Because you got to think about it. Anything in the cloud is, to some degree available and accessible globally. So some of the assumptions that we're making for on-prem just simply don't apply to the cloud from that perspective. So with that in mind, what did we do for this research project? What we did for this research project is first went ahead and went to every single cloud provider. So we have this for AWS, Azure, and GCP. And we went and looked at all their controls, not features, but security controls. Once we understood what security controls were available, we actually did a detailed analysis, helping them understand what's available there. And then we mapped them to the tactics, techniques, and procedures, basically current cloud threats, so that you had an understanding of how to prevent these. And the output of this project was here to support, one, we wanted to empower organizations to understand what are the native controls available for each of these. And then, the output of that was actually the security stack mappings that I'm showing you here today. And essentially what we did for these stack mappings is we went ahead And for every single control, for example, here we have Azure Active Directory password protection. We provided a nice description to help you understand what this control is about. We added some tags to help your team recognize and understand what are the different things that we can have an effect here. And then we mapped out all the different attacks. So you can see password guessing, password cracking, password spraying. These are all different tactics, techniques, and procedures that this control can actually mitigate or detect. And as a matter of fact, we tell you, is it protecting, is it detecting, or is it providing an automated response? And finally, we give you a link to the resources so that your team can have an understanding of how they can actually implement this control. And the value of this is that if you're, the business needs to go on cloud because there's massive, not only cost savings, but the ability to work faster than your competitor in the cloud. So the migration is going to happen regardless. You can take advantage of these native controls to get started, and then think about the longer process if you're in that situation. And what this does is if you're using Active Directory in Azure, if you're using servers in Azure, or if you're using containers in Azure, we've mapped out all the different controls that are available for you natively to leverage and use as part of this process. And again, with the adversary emulation plans that are provided, you can go back and implement and test those controls to ensure that they're actually effective and do so on a continuous basis. And again, your team can do this once a month, once every 3 months, or once a week, some organizations do. Really, the idea here is for you to better understand where are the failures occurring so that you can establish a process to ensure that it doesn't happen again, just like we do with many of our processes at our organizations today. And at the end of the day, this project specifically is going to give you an understanding across all the threats specific to cloud. What is available to me here? And you can see basically the purples are things that Azure controls can mitigate. The blue ones are things that Azure controls can detect. And then the green ones are ones where we have automated responses built into these processes there from that perspective. Yeah, and I think here, how does this compare to the security recommendations that these cloud providers have? For smaller organizations, it's nice to have a gauge and recommendations to measure against. I would say that what this has done is it's actually gone ahead and actually mapped out all the security controls and then given you an understanding of these are the threats I care about. If you recall earlier, we were talking about these are the threats that are targeting financial organizations. You're actually going to be able to have a direct link to the control that's available to you in cloud today, meaning you can hit a button and turn it on, maybe do a little bit more and turn it on. So that's going to be the value where I think today the vendors are really taking the perspective of here's a control and they describe it. And it's really hard to understand how that ties to a real world threat. Well, MITRE ATT&CK is built to describe a real world threat, and they've done that linkage for you. So I think that's the benefit here as well. And then in terms of, do we have recommendations for various PaaS services? So product as a service in AWS and Azure Cloud? Absolutely. It's not in the slides, but for example, Kubernetes would be a product as a service that you might have. We absolutely have Azure Kubernetes controls mapped there. So those type of controls are absolutely mapped as part of this project. So those are, at the end of the day, testing your security controls in some shape, way, or form, beyond the once-a-year pen test is absolutely necessary. I've shared a few ways that you can actually accomplish that today through some research projects that we've done with MITRE. The last thing I want to leave you with is going to be the AttackIQ Academy. This is actually something that we built about 4 years ago. This is our way of giving back to the community. So shameless plug here, because this is our way of actually giving back to the community, where your team can actually come in here and have free courses. We actually have labs that go along with the courses, so they'll be able to apply the concepts. And we even test out to make sure that the concepts are actually understood by the users. And our users that are part of this academy actually get free CPE credits as part of that. And we're not only covering the concepts that I talked about today, the projects that I talked about today, but things like operationalizing MITRE ATT&CK, how to establish a purple teaming program, how to implement a breach and attack simulation program, all different courses and paths of learning that you can take. And again, 100% free. This is our way of giving back to the community. You get free CPE credits as part of this. So for your analysts that need those for their CISSP, this is a great way of them getting some credits. And the other thing I like to mention, if you see there on the bottom right, evidence-based security management primer. This is an example. We also have outside folks that come in and give courses in our academy because they wanted to contribute and they wanted to give back. And by the way, we have over 40,000 students globally today that are participating in this academy. So in terms of following up in some of the items that I talked about today, just take the course on AWS or Azure mappings or GCP mappings, depending on where you own and operate your cloud, so you can see how to implement this or any of the other concepts that I talked about today. That's all I have for you today, teams. Thank you for the feedback. Really happy that I was able to give you this information today. If you think of anything at all, please reach out through the Sync team, or as you see my emails right there, happy to answer any questions.